Every star has a story to tell, and the origin of that story is shared with many other stars. Around 4.6 billion years ago, deep within a giant cloud of gas and dust, anywhere from several hundred to tens of thousands of stars were born together in a cosmic nursery. These stars, including our Sun, share a similar chemical makeup, and what they carried with them has shaped everything in our solar system as we see it today. In this story, we'll uncover the birth of the Sun, the chemistry of its stellar family, and what happened to those sibling stars after they left the nursery. Billions of years ago, the Milky Way was home to a massive nebula, a vast cloud of hydrogen, helium, and traces of heavier elements like carbon and oxygen. Over time, the shock waves from supernova triggered the collapse of certain parts of this cloud. As these regions compressed under the force of gravity, hundreds of clumps formed, each destined to become a star. Our Sun was one of them. As the gas collapsed, the temperature soared, and at the core of what would become the Sun, nuclear fusion ignited. Hydrogen atoms fused into helium, and with that, the Sun began to shine. But our Sun was not alone. We don't know how many other stars were born along with the Sun, but we do know it was just one in the cluster of perhaps thousands of stars. All the newborn stars formed from the same gas cloud, sharing the same chemical origins. What's fascinating about this nebula is that it didn't just produce one star, it created an entire family of stars with almost identical chemical fingerprints. You see, the gas and dust in the nebula were enriched with elements from earlier generations of stars that had died long ago. Hydrogen and helium dominated, but heavier elements such as oxygen, nitrogen, carbon, and even iron were present in small quantities. Every star that formed from this cloud, including the Sun, inherited the same chemical composition. This is one way astronomers can identify the Sun's long-lost siblings today. By analyzing the light from stars, astronomers can determine their chemical makeup. If a star has a similar elemental composition to the Sun, it's likely they were born together. One such star, HD 162826, has nearly the same chemical recipe as our Sun, suggesting it's a stellar sibling. Water is one of the most vital ingredients for life as we know it. And the water we find on Earth, in comets, and even on distant moons and planets didn't form here. It has ancient origins dating back to the very nebula that formed our Sun and solar system. Within this nebula, at extremely cold temperatures, hydrogen and oxygen atoms combine to form water molecules, mostly in the form of ice. As the Sun's gravity pulled together the gas and dust that would become the solar system, these water molecules were preserved, frozen onto grains of dust and embedded in comets, asteroids, and even the building blocks of planets like Earth. Since this water was present in the cloud that formed our Sun, it's likely that many of the Sun's sibling stars also carried water into their own solar systems. If other stars formed planets, and many of them did, then the ingredients for water-rich worlds likely exist elsewhere, scattered among the stars. As the Sun and its sibling stars grew, the remaining gas and dust in the nebula were blown away by powerful stellar winds. The gravitational forces of the surrounding galaxy tugged at this stellar family, slowly pulling them apart. Over millions of years, the Sun and its siblings began to drift away from their birthplace, each embarking on their own journey through the Milky Way. Today, the stars that were born alongside our Sun are scattered across the galaxy. Some, like HD 162826, may be relatively close, about 110 light-years away. Others may be hundreds or thousands of light-years distant. And some of the more massive stars in the family may have already died, their lives ending in spectacular supernovas, leaving behind black holes or neutron stars. But here's the amazing part. If our Sun's siblings carried the same water-rich material into their own planetary systems, there could be countless worlds beyond our solar system that have water. We've already discovered water on moons like Europa and Enceladus, hidden beneath icy crusts. These findings suggest that water might be more common in the universe than we once thought. Since water was present in the nebula that birthed our Sun, it's possible that water exists in other planetary systems formed from the same cloud of gas and dust. Some of these exoplanets could even be orbiting the Sun's lost siblings, still carrying traces of that ancient nebula. While the Sun may have left its birthplace billions of years ago, it remains connected to its stellar family through the shared chemistry of that ancient nebula. The water we find in our solar system, from Earth's oceans to distant icy moons, is part of that cosmic heritage. And as we continue to explore the galaxy, we may find more stars and planets that share the same origin story, perhaps even places that, like Earth, could harbor life. Our Sun's journey continues, but it carries the memory of its cosmic family. As we look deeper into the universe, we are reminded that our star and the water that sustains life are part of a much larger story, one that spans light years and eons, linking us to the stars.